inverse Fourier transform, Fourier sine transform, Fourier cosine transform, and the classifications available. So we have to give importance to three formats. One is Fourier transform, the second one is inverse Fourier transform, and the second classification is Fourier sine transform and inverse Fourier sine transform. The third one is Fourier cosine transform and the inverse Fourier cosine transform. So Fourier transformation is nothing but, first of all we have to know something about transformation. Transformation is nothing but a markable change in nature or in appearance, or it is a process by which the function or expression can be converted into similar format. That is the transformation. Here we have considered Fourier transformation. So we have to represent a function in the form of x variable. So we have to transform that variable from x to s variable. So that is nothing but Fourier transformation. The definition is that f of x be a function defined in the interval minus and plus infinity and piecewise continuous in each finite interval absolutely integrable in minus and plus infinity. Then the Fourier transformation of the given function f of x is nothing but f of x is equal to 1 by root of 2 pi integral minus infinity plus infinity f of x into e power s dx. This is the base formula for Fourier transformation. And we have to go for inverse Fourier transformation also. So inverse Fourier transformation is nothing but f of x is equal to same 1 by root of 2 pi integral minus infinity plus infinity f of x into e power minus as into dx. So Fourier transformation of the given function has been represented in the form of f of x, and f of x is nothing but the inverse of that particular Fourier transformation. Clear? Then Fourier sine transformation is nothing but fs of f of x is equal to root of 2 pi integral 0 to infinity f of x into sin x into dx. And inverse form is nothing but f of x is equal to square root of 2 by pi integral over 0 to infinity fs of f of x into sin x into dx. Here the Fourier transformation will be in the form of x. That is, we have to integrate the function that is available in terms of x. Then the resultant variable will be in the form of s. So a function has been considered in the form of x variable and it will be transformed into s variable. Then Fourier cosine transformation is nothing but fc of f of x is equal to root of 2 by pi integral over 0 to infinity f of x into cos x into dx. And inverse format is nothing but f of x is equal to root of 2 by pi integral over 0 to infinity fc of f of x into cos x into dx. So we have to consider the given function in the form of x. Then we have to transfer that into the variable s. This is nothing but transformation. Yeah. Can we continue? So partial identity is nothing but if f of x is a given function, once again defined in the same interval minus and plus infinity, then it satisfies identity integral minus infinity plus infinity modulus of f of x the whole square equals into ds is equal to integral minus plus infinity modulus of f of x the whole square into dx. So this is nothing but partial identity. Then we have to give importance to some function, some result. So even function and even function will become even function. Odd function and odd function will become odd function. Then odd function and even function will become odd function. So these are the important results we have to consider. Then if the function that we have considered is an even function, then the integral will become integral minus infinity plus infinity. Integral minus plus infinity f of x into dx will become 2 times integral over 0 to infinity. Here we have taken the interval as minus infinity plus infinity. If the function is an even function, we can consider that in the form of 2 times integral 0 to infinity, because if we consider the interval as minus infinity plus infinity means this is 0. If this is an even function, then minus infinity plus infinity and 0 to infinity will be symmetric. So we can, if we fold this means we will get 2 times interval, 2 times integral over 0 to infinity will be there. So integral over minus infinity plus infinity will become 2 times integral over 0 to infinity. If this is an even function, these two parts will be symmetric. So we can consider this interval minus infinity plus infinity as 2 times integral over 0 to infinity. Under the condition, it must be an even function. If the function is odd, means the total value will become 0. So integral of minus plus infinity f of x into dx will become 0 if the function is odd. Okay. So just for example, we can take one function. We have to find the Fourier transformation of the given function f of x is equal to 1 minus x square. Under the interval modulus of x is less than or equal to 1. Other than that interval, all the values will be 0. After getting the result, we have to prove that this condition. After that, we have to prove that this part integral 0 to infinity will be equal to first result, and we have to go for second result. If we want to find the Fourier transformation, means we have to go for this formula. This formula. This is the base format for Fourier transformation. So if you want to find the Fourier transformation of the given function f of x, means we have to give importance to this format. After that transformation, after getting the Fourier transformation format, we have to deduce two results. You can see the result here. So this is the first result. This is the first result we have to find, and this is the second result. So after getting this Fourier transformation result, we have to go for this one, and we have to go for this one. If we want to find the first result, means we have to use inverse Fourier transformation formula. For first result, we have to find the Fourier transformation of the given function. After getting this Fourier transformation, we have to go for inverse Fourier transformation format. So if we apply inverse Fourier transformation format, means we will get this result. After that, we have to give importance to Parseval's identity. Then if we apply Parseval's identity, means we will get this result. So we have to give importance to three formats. First one is Fourier transformation, the second one is inverse Fourier transformation, and the third one is Parseval. This is the thing we have to do. So we have considered a function in the form of f of x is equal to 1 minus x square, and the interval is modulus of x is less than or equal to 1, and the second one 0, modulus of x is greater than or equal to 1. So in between the interval, actually this modulus of x is less than or equal to 1 represents the x variable lies in between minus 1 and plus 1 only. But the format is minus infinity plus infinity. But we have the result for minus 1 to plus 1 only. So minus infinity to minus 1 will be equal to 0, and 1 to infinity will be equal to 0. So we have to give importance to minus 1 to plus 1 only. Left hand side of that will become 0, and right hand side of that interval will become 0. This is the thing we have to give importance to. So Fourier transformation of f of x is nothing but f of x is equal to 1 by root of 2 pi integral of minus 2 plus infinity f of x into e power I x into dx. And the function we have considered is nothing but 1 minus x square in the interval minus 1 to plus 1 only. So we have to split this interval into three formats, three classifications. The first interval will be in the form of minus infinity to minus 1, and the second one will be minus 1 to plus 1, and the third one will be 1 to infinity. Why we should consider like this means the x value lies in between minus 1 and plus 1 only. So we have to subdivide the given interval into three parts. The first part is nothing but minus 1 to plus 1, and here they have mentioned that the answer as 0. That will become 0 if the function lies beyond minus 1 and beyond plus 1. So the first result will become 0, and the last result also will become 0. And the second interval is minus 1 to plus 1. In that case, we can take the function f of x as 1 minus x square. So it will become 1 by root of 2 pi integral of minus 1 to plus 1, 1 minus x square into e power I x into dx. Before integration, we have to represent this e power I x in the form of cos theta plus I sin theta. I think we have studied in 11th standard in complex numbers. We have studied De Moivre's theorem. In that, if we want to represent e power I theta, means we can consider that as cos theta plus I sin theta. So I have considered that format here. E power I theta is nothing but cos theta plus I sin theta. So we can consider this e power I x as cos sx plus I sin x. You just see here. If it is I theta, means here we have considered theta only.